In this question, there is a boat which is standing in still water. There is no friction between boat and water. A man A of mass 50 kg is standing on this side and a man B of mass 60 kg is standing this side. The length of the boat is 4 meters and the mass of the boat is 40 kgs. Now what happens is that A and B decide to come to the center of the boat and meet. So A and B come to the center of the boat to meet. So the question is, in this process in which A and B come to the center of the boat, how much does the boat move in water relative to the water? How much does the boat move? You have to find out that. Now in this question, the first thing that should come to your mind is that this question will be solved by the concept of center of mass. The first thing you realize is that if you take this 40 kg object and the two men in a system, there is no external force acting on the system in horizontal direction. So the net external force acting on the system of both and A and B in horizontal direction is 0. So when the net external force is 0, we know that the acceleration of center of mass is 0, because the formula always is F net external, that is net external force, summation of all the external forces, is equal to mass of the object into acceleration of center of mass. This formula is always true. So when the acceleration of center of mass is 0, the velocity of center of mass will never change. Now in this question, initially everything was at rest, due to which the initial velocity of center of mass, we write this as UCM, was equal to 0. Now the initial velocity of center of mass was 0, the acceleration of center of mass is 0, the acceleration of center of mass is 0, that means the velocity does not change. So the velocity does not change from the initial velocity. So the velocity of center of mass always remains 0. Now when the velocity of center of mass always remains 0, the displacement of center of mass will be 0 again. So in this question, we see that the displacement of center of mass will also be 0. You remember this important sequence. This is an important sequence which I am repeating. When the net external force is 0, then the acceleration of center of mass is 0. Now if in this case there is an additional feature that the initial velocity of center of mass was also 0, then the center of mass always remains at rest, due to which the displacement of center of mass becomes 0. Now this is the important concept which we are going to use in solving this question. This thought came to my mind because this question involved a lot of displacement, that this object is moving something, object B is moving something, and we have been asked as to how much will the boat move. So the first thing that came to my mind is that let us check what is happening to the displacement of center of mass. Even if the displacement of center of mass would have come out to be some value, I would have equated the total displacement to be equal to the displacement of center of mass according to the formula of center of mass. Center of mass's displacement, which is displacement of center of mass is equal to m1s1 plus m2s2 plus m3s3 and so on upon m1 plus m2 plus m3 and so on. So let us apply this in this question. Now while writing the displacements, you have to be very careful about the directions, because displacement is a vector quantity. Let us take this direction to be positive and this direction to be negative. Let us assume this was the initial position of the boat and the two men. Let us assume that the boat has got displaced by a distance x on the left side. So the boat now comes to this position. The two men are at the center of the boat now. This is the final position. Now we need to write the total displacement of center of mass. Displacement of center of mass is equal to, now the three objects we have here are m1, m2 and m3. So let us write for m1 first. M1 was 50 kgs. 50 into displacement. We are writing this equation with respect to ground. So we need to find out the displacement of m1 with respect to ground. Now we know the displacement of m1 with respect to boat, which is 2 meters. This man has moved 2 meters relative to the boat. So the displacement of man A with respect to ground will be equal to displacement of man A with respect to boat plus displacement of boat with respect to ground, because we know that always in vector quantities velocity of A with respect to C is equal to velocity of A with respect to B plus velocity of B with respect to C. Same goes for displacement. So we can write this as displacement of man A with respect to boat was 2, displacement of boat with respect to ground was x on this side. Therefore, the total displacement of man with respect to ground is 2 minus x on the right side. That is equal to 50 into 2 minus x. Make sure you write all these terms very carefully. Now for the second man, this was for man A. For B, let us see what happens. The displacement with respect to boat is 2 on this side. The displacement of boat with respect to ground is x this side. Therefore, the total displacement is the summation of these two, that is 2 plus x with respect to ground on the left side. So we write this as 50 into 2 minus x plus 60 into minus of 2 plus x, because this 2 plus x is on the left side, which we have taken as negative. So we write this as minus of 2 plus x. This is the place where most of the students commit mistakes. So be careful over here. Plus the boat 40 into minus x upon the total mass, whatever that be, because we need to make this quantity 0. So we just need the numerator and make it equal to 0. We need not find out the denominator. So while solving this, we make 0 is equal to 50 into 2 minus x minus 60 into 2 plus x minus 40 x. So in solving this, we get x is equal to minus 20 upon 150 meters. That is, x is equal to minus 13.33 centimeters. So final answer for the displacement of boat is that. Now this answer has come out to be negative. That means it was actually minus 13.33 in this direction. That is 13.33 on the right direction. So final answer is the displacement of the boat relative to the water was 13.33 centimeters on the right side.